Okay, so this is the first set of notes introducing solutions. So this is in a unit that's all about solutions. And the first thing that we're going to do is do a little bit of a throwback here to Unit 2. So it says, if we're looking at these different things here, which of these do you think are solutions and which are not solutions? And so if you want to pause the video and think about that for yourself, maybe that would be good. Otherwise, I'll just sort of move on and explain. So the first thing you have to know here is that solutions are homogeneous mixtures. That's what a solution is. So a homogeneous mixture means that it's a mixture of two compounds or elements together, and it also has to be the same throughout. That's what homogeneous means. And so on that list, distilled water is not considered a solution because water itself is a pure substance. So it's not a mixture, it's just pure water. And so that wouldn't be a solution of two or more substances together. The dressing and the chia seed drink, if you look at those ones here, they have specific bits in there that you can see that are different than other bits. So those are definitely heterogeneous, which means that those are certainly not solutions. They're certainly not homogeneous. Milk, on the other hand, we'll get to talking about here. Hopefully you'll remember that milk is a colloid. What makes something a colloid is when it has things that stick together that are larger than atoms and molecules. And so what we've got here is, it says a true solution down here at the bottom. In a true solution, those little particles that are floating around, those are like individual atoms and molecules, super small little things. For a colloid, we've got larger chunks of things. These can be 100 times as large as the atoms and molecules. And what we get there are like clumps of fat and things like that in milk. And so that's different than having just individual atoms. And so what we say here is for colloids, we say those aren't true solutions. Those are heterogeneous, and so we don't consider them. Over here we talk about suspensions. This is something kind of like that chia seed drink where you've got visible particles. They're suspended in a liquid. They look like they're floating there. Colloids and suspensions oftentimes will settle out. Solutions don't settle out. So that's something that makes solutions unique. So going back here just to talking about the definition of a solution, it's two or more substances mixed together. Uniform throughout means that it's going to be the same all the way through. Any bit of the solution is going to be like any other bit of the solution. Here are some examples, although these are sort of some interesting pictures to choose here because I'd say that arguably a couple of these are not actually solutions if you look at them. Maybe take a second and pause the video and try and think about which two are not solutions. All right, the two that are not are this one over here because it's got ice in the soda, which makes it heterogeneous. And the Alka-Seltzer tablet, that one will be homogeneous after the tablet dissolves. But right now, as we've got the tablet in the bottom and we've got these bubbles up here, that's not going to be homogeneous. That will be a heterogeneous mixture. And so that one's not fully a solution yet either. All of them will be eventually, but yeah, you got to watch out for those sorts of things. So there are two parts of solutions. The first part is called the solute. That's what's being dissolved. Right. The second thing is going to be called the solvent, and that's what is doing the dissolving. You're putting the solute into the solvent. And so we use an example here of Kool-Aid. The little packet, the little Kool-Aid flavor packet, that's going to be the solute. It's in a small quantity. We're going to put it into the water, which is in large quantity. And so the water in that case is going to be the solvent. The way that I remember this is that solute is kind of like the word salute. And so I think of like a lower ranking soldier saluting a higher ranking soldier. And so the one that's in smaller amount is the solute. The one that is larger amount is the solvent. All right, I've said that we've got really, really small particles in solution on the order of atoms and molecules, very, very small. They're going to be evenly distributed throughout, and they're never going to separate. And so that's a little bit of a difference because with colloids and with suspensions, they will separate over time, but solutions do not. Okay, now we're going to talk about different ways that we can improve the way that things dissolve into liquids. So the first thing that you can do to help things dissolve is you can mix them. What this does is it's going to break the crystals up a little bit more. They're kind of in a pile on the bottom a lot of times when you dump them in, and so by breaking them up and exposing more of them to the water, it will dissolve faster. The other thing is, as water's flowing by the crystals, if you've got lots of moving water, as it flows by, it sort of pulls the edges of the crystals off. So that's what's going on there. If you mix it, it speeds up dissolving. Also, if you heat something up, it dissolves faster. We use the example here of hot cocoa. If you put the mix, the cocoa powder mix, inside cold water or with cold water, it's not going to mix in very well. If you put it, however, in warm water or warm milk, it's going to dissolve. And so heating helps things dissolve. The reason for this is because the particles in the solvent, the liquid, are going to be moving faster, and that allows them to sort of break into the solute a little bit faster and break apart those crystals. The third thing we can do is we can increase the surface area, and so this asks if we're talking about a cube of sugar like you would put in your tea, or a grain of sugar well, actually probably an equal amount of sugar to what you have in the cube, but just in grains, like which one would dissolve faster, is going to be the grains. And the reason for this is because there's going to be more surface area available when it's broken apart into smaller pieces. And so if you think about, I use another analogy, if I wanted to put peppermint in my tea, and I had a peppermint candy that I had bought from the store, and I wanted it to dissolve in the tea. If I just dropped the peppermint in by itself, it would take maybe a long time to dissolve. But if I crushed it up into like a powder and sprinkled it into the tea, it would dissolve much, much faster. And so that's a third way that we can dissolve things a little bit faster, is by increasing the surface area or crushing them up. So now I'm going to go into a bunch of different types of solutions. The first one, you might not normally consider this to be a solution, but technically speaking it is. We call them solid solutions, and in this case, a solid is the solvent, and so usually the most common examples of these are alloys, and really the way that we'd make an alloy is by melting the two metals down, mixing them together, and letting them solidify. But these are homogeneous mixtures of two substances, and so we do consider them to be a solution. But they've got a solid form. They're as solid as the solvent. We can also have things dissolved in gases, and that usually actually just comes about in the example as like a mixture of gas. So air, for instance, is a mixture of oxygen and nitrogen. In surgical gas, we have oxygen in there, but we also have the gas that makes you sort of fall asleep. Okay, now the most common type of solution that we normally talk about is liquid solutions. That's where liquids are going to be the solvent. And there are a bunch of different subtypes here. So we can have a carbonated beverage where gases are dissolved in a liquid. So that's a liquid solution because liquids are the solvent, but you can have gases dissolved in there. Carbon dioxide is the gas that's dissolved in soda and things like that. So when you think about carbonated beverages, that's typically going to be carbon dioxide in there. Another type of solution where you have a gas dissolved in a liquid is if we have a fish tank, for instance. You need to make sure that there's oxygen dissolved in that fish tank because the fish breathe oxygen, and so they're going to need to have access to that. And so usually there's something called an aerator, which helps to put air into the water so that oxygen can dissolve and the fish can breathe. Another thing we can do is we can dissolve a solid into a liquid, and so that Kool-Aid example or salt water or something like that, you put a solid into a liquid and it spreads out. The third kind here, you can have a liquid in a liquid. So typically alcoholic beverages, those are mixtures of water and alcohol to different various degrees depending on the alcohol content. And so those mix together pretty well. Some liquids don't mix together, and we'll talk about this a little bit later on when we talk about solubility. But because water is polar and alcohol is polar, they mix together very well. This is kind of a review, but aqueous solutions have water as the solvent, so it's going to be when you dissolve something in water. There are actually two subtypes even of that. So one is called an electrolyte or an electrolytic solution. What this is going to have is ions dissolved in it, and it's an aqueous solution. It conducts electricity. All right. You might have heard electrolytes are in Gatorade. That's one of the things that they say. It replenishes your electrolytes. And what that's really meaning is it's going to replenish the salt and the things like that that come out when you're sweating. And so that's why Gatorade is a little bit better than just water, because it has a high concentration of those electrolytes in there. Although I'll say tap water itself actually has electrolytes in it. It has things from the pipes, you know, it's got the fluoride in there that they put in intentionally. So there's lots of different things actually in tap water that make it an electrolytic solution, but not to the level that Gatorade is electrolytic. The other type of solution we have is a non-electrolyte solution. Pure water, so like distilled water, won't conduct electricity by itself. And if you put in something here like sugar, which is not an ionic substance, that won't conduct electricity either. The reason that you need ions to conduct electricity in water is because ions are little charged particles, and whenever something's conducting electricity, basically what it's doing is creating a conduit for electrons to move through it. And so if there are ions in there, what can happen is the electrons can kind of hop from particle to particle within the water. If there are no ions in there, then there's nowhere for the electrons to go, so they just can't travel through the water if it doesn't have the ions in there. The last thing we're going to talk about here with solutions is going to be concentration. And so we've got a picture here on the side of orange juice from concentrate. And so if you think about what the word concentrated means, you might come up with something like the amount of a substance inside of another substance. In this case, it's going to be the amount of solute in a given amount of solvent. And so if you had something concentrated, that means that there's a lot of it in just like a little bit of space or a little bit of stuff. And so this is what the chemistry definition is: relatively large amount of solute dissolved in a solvent. You might use the word dilute as the opposite of concentrated. That means that there's not very much solute in there. And so we do this Kool-Aid lab where we talk about concentration. And so like really, really strong Kool-Aid, if you're someone who likes lots of sugar and flavoring in your Kool-Aid, don't use much water, that's going to be concentrated. Something that's dilute would be very watered down. It wouldn't have very much in there. So we use this unit molarity to express concentration. There are actually other units. Molality we'll talk about later on this unit, parts per million, percent composition, things like that. But we're going to talk about here just molarity today, so you get introduced to how that works. And so it's a unit that expresses concentration. If you think about this, 1 molar versus 16 molar, and try and decide which one's more concentrated, I think you'll have the right sort of idea there. It's going to be the higher number is more concentrated. And this is the actual definition of molarity. So molarity is the number of moles of solute you have per liters of solution. And so it's important that you keep these words in mind. So solute, remember, is what's being dissolved. The solution is the mixture of the solute and the solvent together. And so you can't have moles of solute per liters of solvent. That's not the same thing. When you put the solute into the solvent, it actually adds a little bit of volume there. So let's say that I had something like 35 grams of salt, and I was dissolving that in water, and I had 1 liter of water. When you put the salt in the water actually, it becomes salt water, but there's more than a liter there. It takes up more space by adding the salt. And so you need to be careful to distinguish between liters of solution, which is after you mix them together, and the liters of the solvent, which is just the water before it's mixing. If I give you something like moles, something like grams, you have to convert it to moles. If I give you something like milliliters, you have to convert it to liters. Because if we're getting molarity out of this, molarity is specifically defined as moles per liter. All right, so there are some practice problems on this, but they're in another video. So if you want to watch the molarity practice problems, you can go ahead and find that video. It's been posted as well. So other than that, if you just have any question about these sets of notes, make sure that you come in and you ask me about it. Thank you.